Hello everyone. Today we're going to be learning about solving nonlinear systems. So a nonlinear system is a system where at least one of the equations is, as you can guess, nonlinear. And so we're going to be looking at two different types of nonlinear systems today. First is a linear/quadratic system. So that means that one of the equations is quadratic and the other is linear. And we see that we can have three types of solutions that can occur. First is two solutions, so I see that these two graphs intersect at two different points, so those would be my solutions. We can have one solution where they only intersect at one point, or no solution where we see they do not intersect at all. And then we're also going to look at quadratic/quadratic systems. So here we have two quadratic equations, and we're finding the solution of it. And again, we can have two, one, or no solution. So two solutions where they intersect at two different points, one solution where they intersect at one point, or no solution where they do not intersect at all. So first, let's go ahead and solve a nonlinear system by graphing. So to do that, we're going to go ahead and graph both of these functions, and we're going to see where they intersect at. First, I want to go ahead and graph x squared minus 2x minus 1. When it's in standard form, we learned in our previous unit that we can find the vertex first, and then use that 1, 3, 5 rule to create other points. And so my vertex is going to be the x-coordinate is opposite of b over 2a. So my a here is 1, my b is negative 2, my c is negative 1. So the opposite of negative 2, I get positive 2 over 2 times 1. Well, 2 divided by 2, I just get 1, so x equals 1. So my vertex starts with 1. Now I need to find my y. And to find my y, I just need to plug it back into the equation. So I have 1 squared minus 2 times 1 minus 1. Well, I have 1 minus 2 minus 1. 1 minus 2 is negative 1. Negative 1 minus 1, I get negative 2. So my vertex is at 1, negative 2. So I'm going to go ahead and plot that. And then we can go ahead and use our 1, 3, 5 rule to create other points. Since my a is just 1, I can just use 1, 3, 5. I don't have to multiply it by anything. So that means I'm going to go up 1 over 1 on both sides of my vertex. And then up 3 over 1. And then up 5 over 1. And then draw my parabola. Okay, so we have our parabola graphed. Now I need to go ahead and graph my line. And so here it's in slope-intercept form. So my slope here is negative 2, or in other words, negative 2 over 1. And my y-intercept is negative 1. So to graph this line, I'm going to start at negative 1 on my y-axis, which is right here. And the slope of negative 2 tells me I'm going to go down 2 to the right 1. And then I can also go the opposite direction by going up 2 to the left 1. So I see in this graph, it intersects the parabola at exactly 1 point at my y-intercept. So the answer here is going to be 0, negative 1. Okay, let's try one more. Here I have y equals x minus 1 squared, and I have y equals x minus 4. I see this x minus 1 squared, that is already in vertex form, where my k is just going to be 0. So that means that my vertex is 1, 0. So I'm going to plot that. And then my a again is just equal to 1, so I can follow that 1, 3, 5 rule. So I'm going to go up 1 to the right 1, then up 3, and then up 5. And then I'm going to draw in my line. So here my slope is 1. My b is -4, so I'm going to start at -4 on my y-axis. And I'm going to go up 1 to the right 1. And also go the other direction. And so I get this line here. Here I see that my two graphs do not intersect at all. And so when it does not intersect, that is going to be no solution.